Hello everyone, we're live.
Welcome to this 2021 edition of the Northwestern European Regional Contest. We are live from Reykjavik University, Iceland, and we are going to be your host for the weekend. My name is Unnar, and I am the contest director for NWERC.
And my name is Bjarki. I'm the technical director and the head of judges of the NWERC 2021 jury.
We will be your host for the live stream, and we would like to start off this weekend by having a small message from our lovely Dean of Computer Science at Reykjavik University, Luca Acedo. Luca, please take it away.
Good morning, everyone, and welcome to Reykjavik University, albeit virtually, for NWERC 2021. This year is a bit special for me because I get the chance of welcoming all of you twice to Reykjavik University, unfortunately virtually both times. In the spring, we were at NWERC 2020, and now we fast forward to 2021. It's 8 o'clock in the morning on a dark Reykjavik November morning, and it will take about 1 hour and a half for some form of natural light to become visible. But I'm pretty sure that virtually you will light up the Reykjavik sky much earlier than that with your activity and your preparation for the competition tomorrow. The late physicist Freeman Dyson wrote in the text of an Einstein lecture that he gave a few years back that there are two types of mathematicians: the birds and the frogs. The birds are those minds that sort of hover over the mathematical landscape, and they discover new vistas. They give very general theories of which many other phenomena can be seen and instantiations. The frogs, on the other hand, they play down in the mud. They delight on whatever sculptures they can create out of the mud, of the beauty of the little flowers that they see next to their pond. And they solve delightful problems, challenging problems, one after the other. I consider myself to be a tiny toad, a tiny frog myself. And in some way, I believe that you are too. Over the course of the competition and over all the previous competitions that you are going to participate in, that you participated in and the future ones that you may take part in, you will solve one problem after the other, honing your skills and becoming better at the martial art of computational problem solving. You have a superpower, the superpower of computer science, and you're becoming increasingly better at deploying it for solving problems. This is something that will give you a humongous competitive advantage over your contemporaries. Because today, computer science is everywhere. We have no idea what the future will bring. Prediction is very difficult, especially about the future. But let me try. You will be at the forefront of what will happen in the coming years, starting from today and tomorrow. However, with great power comes great responsibility. So I encourage you to use the superpowers that you are developing for everybody's common good in the future. You will stand to gain, the world will stand to gain. We live in an epoch in which we are faced with all kinds of problems. Computer science has to be part of the solution and not part of the problem. So develop your skills as computational problem solvers, as superheroes for the future society, but at the same time, keep an open mind. You are the Renaissance women and men of the 21st century. Read broadly, have an open mind, challenge yourselves, and think about the small problems that you are solving every day, but also the impact that your solutions may have on everyone else. However, that's for the future. Over the coming 2 days, I encourage you to play in the mud, enjoy yourselves, and make it so. So good luck. I remember the last competition. Lost patrons from the University of Oxford won after a titanic battle with a number of other fantastic teams that all managed to solve basically nearly all of the problems, which were actually very challenging from my viewpoint. So congratulations. However, this is not just, this is not only about winning. And in fact, it's not principally about winning. It's about having fun and becoming as good as possible in your superpower. Thank you very much. Enjoy yourselves, and I will be following the competition, even if tomorrow I'm supposed to give a talk at a workshop on teaching computer science. Over to you, Unnar, Bjarki, August, and your team.
Is a journey of uncertainty. From 5G deployment and its ecosystem came digital transformation in all industries. From Huawei Cloud came the wonders of widespread remote healthcare. From AI machine learning came better, more intelligent ways to protect the Earth. From AI computing came advanced astronomy research and a deeper understanding of the cosmos. From new ways to live, a greener Earth, and futures beyond our imagination. Our journey of innovation will never end.
Hello everybody, I'm Andrei and I work for JetBrains as a Senior Vice President of Investments, Research and Education. Welcome to Regionals. Great things happen when great minds come together. JetBrains wants to seek out great minds all across the globe, support their initiatives, and work together to create great things that will make the world a better place. That's why JetBrains is proud to be a Global Tools sponsor of the ICPC. There are already many great minds working at JetBrains, and together we have created some amazing things, like the Kotlin programming language, for example. It keeps on growing and growing in popularity. In 2017, Google began officially supporting Kotlin as a language for writing Android applications. We have also created professional development tools like CLion for C++ programmers, IntelliJ IDEA for Java, PyCharm for Python, and also educational tools that help people learn and teach programming. The regionals are the biggest contest in the ICPC calendar. Thousands of talented people all over the world team up to solve complex real-world challenges. These contests are the proving ground for future champions. But even if you don't make it through to the finals, the experience of competing in the regionals and the new friends you'll make along the way are priceless. Enjoy the ride. Best of luck to everyone.
Thank you, Luca, for a great speech. It's always a pleasure to listen to you talk. An event like this would not be possible without our sponsors, and I'd like to say a special thank you to our global sponsors, Huawei, who are our Diamond multi-regional sponsor, JetBrains, who are our global programming tool sponsor, and AWS, who are our EdTech Gold, ICPT Gold sponsor. And last but not least, Reykjavik University, who graciously has helped us a lot with the organization of the contest and all kinds of other things. Thank you so much. Some numbers. This year we have a record number of participants and teams. We have 467 participants, so that's contestants and coaches, and 134 teams from 60 universities, representing 12 different countries. It's really amazing to have you all competing in our contest.
Yeah. So if you're wondering how do I engage during the event, we have a few different ways of doing that. So first of all, during the live stream, I hope all of you can see that there's this chat panel to the right of the stream. So we'll be viewing the chat during the live stream and answering any questions that you have. So yeah, please let us know if you like the live stream, and we'll be monitoring the chat. We also sent out an email yesterday with a link to our Discord server, which you can access during the entire event. We'd love to get interaction in there. You can get to know your fellow peer contestants. We also have a separate channel called Photos, where we love to encourage you to send us photos of your setup. If you have a silly setup, or if you're wearing a costume during the contest, anything interesting or fun, we'd love to see you share your photos.
Or if you're participating from one of our sites, we have some sites that were organized by some members from the community, for example, in Copenhagen, and we'd love to see some pictures from there.
Yeah.
Special note that we will have a special prize for the best photo, so please send us your best photos.
So there's one thing that you should know about, which is that during the contest, so both during the practice session as well as during the main contest tomorrow, if you need to communicate with anyone outside of your team, it should always be done through the CADDIS clarifications page, which I'll show you in a bit. So if you have any questions about the problem statements, about having issues with CADDIS, any technical issues, please post these questions into the clarification interface on CADDIS. That should be the your only way to communicate during the contest with anyone outside of your team. Okay.
Yeah. So this year we have gone for an online format again, and that means we have some rule changes from the typical ICPC regional rules. So the main ones are you're allowed to compete from anywhere. So you don't have to compete from the same location if you're in the same team. You can use your own computer. It's a given. And you are allowed to use the internet, but there are 2 restrictions to internet usage. As Bjarki mentioned, you're not allowed to communicate with anyone or post any information about the contest during the contest on the internet. So no posting on any forums or anything, no posting the problem set anywhere, and so forth. And you can only read the information on the internet that was posted before the contest started. So if somehow you find some information about the contest that was posted after the contest started, please disregard it, don't read it. You are allowed to use codes that's found on your computer or on the internet. However, if you take code from the internet, we ask you to please provide comments that has a link to the original source. This is just for verification purposes. So feel free to use any code you find on the internet that was posted before the contest starts, but just include the link. You're allowed to communicate with your own team members during the contest, and if you're participating in one of our sites, you are allowed to talk to the site organizers about practical things like going to the toilets, etc., of course. But please do not communicate with anyone, any other teams, or anyone outside your team, and that includes your coach. So no communicating with your coach during the contest. There's no restriction on software use during the contest. You're allowed to use whatever software you would like, any IDE, any editor, anything. Everything is free game. So feel free to use whatever you're comfortable with. Anything you would like to add?
Yeah, I see we have a question in chat from Lucas, who asks, but are you allowed to copy the entire algorithms from the internet? And the answer is anything you can find on the internet, as long as it was posted before the start of the contest, and you include a link to the original source in your source code, then it's fine. So the answer is, in short, yes. Okay, so you'll be using the contest system called CADDIS during the contest. I'm going to do a quick introduction to the CADDIS system. So let's switch over to that. So you should now be able to see a screen on my laptop here. So you should have received in your email credentials for your CADDIS account, as well as a link to the CADDIS online or the CADDIS jets that we have. And when you open that link, this will be the first thing you see. We have the NWERC 2021 practice session about to commence in just over half an hour. So the first thing you need to do is go here and log in. So I picked here a team at random, team number 1, and logged in as that team. So when you're logged in, you're able to see the standings. If you look in the menu on the left, we have the first thing is the standings. This is where you can watch the fellow teams as they solve problems, as well as track your progress during the contest. If you go into the problems tab, this is where you'll see the list of problems, which will become available as soon as the contest starts. Then we have clarifications. So this is the interface that I mentioned earlier. So again, if you have any questions during the contest, this is where you're supposed to post them. Please do not ask on Discord or on YouTube chat or anywhere else, any other forum. This is, if you have any questions at all, this is where you should put them. You can pick a topic, either general or pick one of the problems if the question is about one of the problems. And just ask your question here, submit it, and both the systems team as well as the jury will be monitoring these questions, and we'll get back to you as soon as we have an answer for you. And this will either be posted directly to the team if it's only relevant to them, but if it's relevant for everyone, we will send out a clarification to all the teams, and you will see a small banner up here on the in CADDIS which says that there's a new clarification. And yeah, in case your team members miss it, let them know that there's a new clarification, and you'll be able to find it in the clarifications tab. Finally, we have some documentation here. So depending on which programming language you will want to use, we currently have C, C++, Java, Kotlin, Python 3 available. You'll be able to find some instructions on how to submit code with each of these programming languages. There are also more instructions inside how to submit, how the judging is done, and so forth. I also want to point out here in the upper right corner, you can see your username or your team name. And there are two important things here. So first of all is my submissions. So this is currently empty, but when you make a submission in CADDIS, you'll see your submission listed there. And you can go back, view the source code, see what the verdict was, whether you got accepted, wrong answer, and so on. As well as if you need to edit and resubmit your solution, you can do that easily through by opening up the submission. If you go back up here, we also have profile settings, where there are a couple of settings that you might be interested in changing. We have the language of the CADDIS interface, which is either English, Swedish, or Icelandic. We also have the preferred time zone, which is, I believe, currently the Atlantic/Reykjavik time zone for everyone, but if you prefer seeing time in your own time zone, you can change it there. Then we also have the default programming language. So if your team is using a specific programming language, you can pick the default there, so you don't pick it every time when you start coding. Yeah. One more thing. So we don't have any problems loaded yet because the contest hasn't started. But I wanted to quickly show you what the problem statement looks like. So unfortunately, we redesigned the CADDIS interface recently, and I don't have a way to show you any problems in the current version of the CADDIS interface. But I'm opening up here a problem from last year's contest. This is in Open CADDIS. And this is roughly what the interface will look like when you open up a problem. So you'll see the title, the problem statement, and make sure you have to read all of this, the entire problem statement carefully. You'll also have some sample cases here below. In this case, this is an interactive problem, so you can see sample interactions for this problem. Here on the right, this will actually be below the problem statement in the new version of CADDIS. But here you can see the time limit, how long your solution can run on each test case. We have the memory limit, which in all problems should be 2 GB. And we also have some downloads. You're able to download the sample data files. As well, if this is an interactive problem, you'll be able to download a testing tool. So this is a Python script specifically made for the interactive problem that allows you to test your submission locally. And you can download this and make any changes to the script that you want to assist you with solving the problem. Then finally, when you're ready to submit, in the new interface, it will be slightly different, but on the right side, there will be a way to, of course I can see this, but there will be a way to either paste directly in your source code or select the file from your machine. So let me see.
We have a few questions. Yeah. So what happens when teams are asking about questions about the problem set on Discord? We will close down posting messages on Discord during the contest, so that should not be possible. If a team were to post questions about the problem sets on any other platform, we would kindly ask them not to do so. And if it's a repeat offense, then we might have to take action against that team.
Rick asks, are the questions not public initially? And because we have this
clarifications.
Sorry?
That's regarding clarifications, I believe. So yeah, clarification questions are not public.
Yes, when you post a clarification request, we are the only ones that will be able to see that question. And when we have an answer, we will either post it directly to your team or to everyone, and then it will become public. So initially, the answer is no, the questions won't be public, as long as you post your question inside the CADDIS clarification interface. And this is why we want you to post all your questions in CADDIS, in the clarification interface there.
And a question for the jury, will all problems be able to be solved in all languages, or is Python too slow for some problems?
So we sent out a hints document from the jury where you can read about all kinds of technical questions related to the problem set. And in there you'll find that all of the questions, all of the problems are solvable in C, C++, Java, and Python. But we make no such guarantee about Kotlin.
And the last one, is this a special UI made for Android 21?
I'd love to say yes, but we are in the process of, CADDIS is in the process of being redesigned. So you're getting a sneak preview here at NWERC, exclusively for you. Okay.
So any other final questions before we end this live stream and give you some time to grab snacks or drinks before the practice contest starts?
We'll give you a couple of seconds if you'd like to ask any final questions on the YouTube chat. Can we kiss the trophy? Of course. How would we not allow you to kiss the trophy for good luck? We'll definitely do that as soon as we've answered any other questions. Is everyone feeling good? Are you well prepared, ready for this? Feeling excited? Okay, I'm not seeing any more questions. Isn't kissing the trophy bad luck? Depends. You can decide for yourself whether you kiss the trophy or whether you touch it. Okay, I'm not seeing any more questions, so let me just conclude this part of the live stream. You have a few more minutes, as Unar said, to do any final preparation before the start of the contest for the practice session. The practice session is for 2 hours, and we'll be back with the live stream as soon as the practice session is over. So as a way to kind of wish you good luck, I'm going to take the trophy up to the camera and encourage everyone to touch your screen, lick it, kiss it, whatever you feel is good, as this will give you good luck. All right.
welcome back, everyone. I hope you had a great practice session. Hopefully you found the problem somewhat enjoyable and found out what you needed to, or managed to test your setups for tomorrow. Now we are going to have a tech talk, and today we're pleased to have Michal Podešek joining us for the tech talk. He is a very active community member in the competitive programming community, and has done a lot of things. For example, writing a book about interesting things, and has worked with algorithms, and even is the creator of the Misov tree. So you might know him by his online name of Misov as well. I'm very happy to have him speak to us today, and I hope you will enjoy his talk. Over to you, Misov.
Yeah, pleasure is all mine. Northwestern European regional contest has been one of my favorites. When I was competing in the ICPC, I was the region next door. We were competing in Central Europe, and but I had the good experience of attending the NWERC as well several times as analyst when we were trying out stuff for the World Finals as ICPC analysts and so on. So yeah, Northwestern region is close to my heart, and I'm very happy to be here today and to be able to entertain you for a while with some random talks about stuff I found interesting in the area of cryptography. So hopefully you will enjoy the talk and be entertained, and it will take your mind off the contest for a little while. I will try to monitor the YouTube chat, so if you have questions during the talk, feel free to type them, but probably I will get to addressing most of them only close to the end of the talk. So let's see what we have in store today. So I'll try sharing the presentation, and hopefully everything will cooperate. So looks like it works. Perfect. So let's see what we have in store today. This is me. I was already very nicely introduced. If you have any reason to reach me, you can do it by email at misov@algo.sk. And yeah, I've been doing this for quite a while, and it's still fun. So hopefully I will keep on doing this, and you will keep meeting me if you are still the members of this nice competitive programming community. So today I will be talking about several vaguely loosely connected topics that have one thing in common, that they are kind of related to cryptography. And the topic we'll start with is a topic very near and dear to my heart. It's about physical locks. So these are locks you can find on everyday doors. They are called pin tumbler locks. And the mechanism is as follows. So you have the lock. There is a part that is static. That's on the picture on the left, it's shown in green. And there is a part that rotates. That is the yellow part. So you insert the key, and then you rotate the yellow part. And during the rotation, it will lock or unlock the door. What's going on inside the lock is that there are several pins, and the pins are on springs. And each of the pins is cut in one specific location. And in the position when there is no key, the springs are pushing the pins as high as they can go, and the pins are making impossible for the core, for the yellow part, to rotate. And if you insert the correct key, as is shown in the second picture, it depresses each of the pins exactly so that the place where the pin is cut is exactly on the boundary between the yellow and the green part. So now the top part of each pin is inside the core, the bottom part of each pin is outside of the core, and now the core is free to rotate, and you can actually open the lock. If you insert a different key, then the pins will still be misaligned, and they will still be blocking the core from rotating. So this is what is going on inside your ordinary lock. If you are interested in seeing it in more detail, I recommend the YouTube channel Lockpicking Lawyer. who will show you how to open such locks using almost everything. From the point of view of a computer scientist or a mathematician, what's going on here is that each key and each possible lock can be seen as a vector of numbers, as a sequence of numbers that is describing the way the key is cut. This is called the bitting on the key. So you have a sequence 0, 3, 4, 1, 3, 2 is describing the depths of the individual cuts on the location of each pin that the key has to push down. And in this, so this gives you some idea about the space of possible keys. If the keys, so this is physical, so if you have keys that are very close to each other, then one of them will work and you will just have to use a bit more force. So you need to have some kind of discrete steps. And so on each location, you will have maybe 5, 6, maybe 7 possible depths for the key. And this is then taken to the power of the number of pins inside the lock, and this gives you the number of possible keys. And now we're getting to the interesting part. There are many practical uses for what is called master keys. A master key is a key that can open multiple doors. So a common use for this would be that you have a hotel, and inside the hotel you want to have guests, and each guest should be able to only get into their own room. But you also want to have housekeeping people who come into each of the rooms to exchange towels and clean up and so on. And housekeeping could carry a huge bunch of keys, but it's more practical if they have a master key, a key that can open each and every of the doors without allowing the hotel guests to do the same thing. And with pin tumbler locks, there has been for decades a very standard technique how to do these master keys. And the technique is very simple. The thing you do is you just cut each pin, not in one place, but you cut each pin in 2 separate places. So if we go back to the original picture, now each pin will have not 2 parts, one on top of the other, but there will be 3 parts. And one cut will correspond to the ordinary key given to the guest, and the other cut will correspond to the master key. And you make a separate lock for each of the doors. In each of them, you make one set of cuts in original locations for just that one specific key, and you make the second set of cuts in exactly the same locations in each of those locks, and then the second key, the master key, will be able to operate all of them. So much for the theory, how this has been done. And one day, in early 2000s, computer scientists interested in locks studied this particular application, and the guy by the name of Matt Blaze came up with quite an easy attack on this physical security. So first of all, probably all of you have already made the observation that if you cut the lock like this, there will not be just those 2 keys that work. Each and every possible combination of those keys will also be able to open the door. So if you have, let's make it very simple, if you have one key that is cut to the depth of 3 on all locations, and another key that is depth 5 on all locations, and one of them is the master key, the other is the regular key, then any key that has 3 or 5 on each of those possible locations will be able to open the door. You just need to press each of the pins either to the first depth or to the second depth that will allow you to open the door. So if there are P positions, there are not just 2 keys that work for the door, there are 2 to the P keys. This alone would not be such a big problem because it's still only a small subset of the space of all possible keys. But it's actually possible to very easily obtain the master key in, let's call it linear time, so with the linear time complexity, if you already have the other key. So what you can do is you can check into the hotel, you will get your room, you will get your room key, and now what you already know is one possible vector of numbers, one possible sequence of depths that actually works, that opens the door. And now you can take a blank key profile. So this is a key that hasn't been cut yet. And you can use just an ordinary file to file down the key. And you can file down all of the positions to your room key, except for one. And for this one position, you will now try does it open the door if I don't cut it at all? Does it open the door if I cut it a little bit more? You skip the position that works for your particular key, and you try out all of the other positions. And in this way, you will find out one of the numbers for the master key. Then you do the same for the second, third location, and so on. And the final part of this story is that he wrote this up, published it, and then approached also like some standard locksmiths and talk about this. Hey guys, look what I found. There is this very clear and easy vulnerability. An attacker with half an hour of time can actually determine what the master key is and make them in this way. And he got the response, yes, we all know about this, but shut up and don't tell the general public. So that's the nice part of this story. As usual, in the area of security by obscurity is a bad idea. Sooner or later, somebody will find out the parts that should have been obscured, and then your security is no more. So the only right way of doing security is security by design. The thing that makes it secure has to be something actually designed to be that way, and not just keeping something quiet. So this was our first topic. Now let's try something different. With the advent of communications all over the world and so on, many things that have been very easy have now become much more complicated. And things like flipping a coin can be very tricky if one of you is in Europe, the other one is in Australia or whatever other side of the world. If you are in the same room, flipping a coin is trivial. You take a coin, you flip it, and both of you observe the coin. One of you calls heads or tails, and then you look at the coin and see who won. But if you are on the opposite ends of the world, then it's not immediately obvious. How can you flip a coin? Or maybe how can your two smartphones flip a coin in such a way that both of you trust the result? There are many ways of doing this that are not that good. I mean, for example, the way that, okay, so I'll flip the coin and I will tell you the result. So just trust me. I can even do it on camera. No, I don't have it pre-recorded, and I will not select the recording that is opposite to the one you make as a guess. Or maybe let's both flip a coin. You will flip a coin and generate a 0 or a 1. Then I will flip a coin and generate a 0 or a 1. Then we'll take the XOR and we'll use it as a result. Yeah, okay. But now my friend is saying, hey, why should you throw the coin as the second one? What about you start and then I will throw the coin to generate the result I want to have? Okay, this will not work. Okay, no. Now, so maybe let's just give up and let's use a trusted third party. There is random.org, so let's use that as the source of our random bits. Okay, this works if we want to flip one coin, but if we want to have an application we are selling and people are using the application to play some games against each other and so on, and maybe it will be too expensive, maybe they will rate limit us too much or something like that. So it would be better if we had a solution that doesn't need a trusted third party. Is there something we can do? Here's a better protocol for flipping a coin. Alice will say that, okay, I have made my guess. I have chosen heads or tails, but I'm not telling you yet. I have written it down. I have sealed it into an envelope, and here it is. Here's the sealed envelope. And now Alice will mail the envelope to Bob. Bob will wait until the envelope arrives. And then he has the flipped envelope, the sealed envelope. He can flip a coin, announce what's the result, and only then they will unseal the envelope and take a look whether Alice was correct or incorrect with her guess. Of course, so this works. This kind of doesn't break anyone's trust, but with physical envelopes, it will be too slow. So here's a way to do the same thing, but with standard tools you have on your computers. So Alice will create a text file with the text, I will choose heads or I will choose tails. She can then produce, for example, an encrypted zip file, email the file to Bob. at this moment, Bob has the encrypted zip file, and he knows that Alice is committed to a choice. So this is why it's got the official name, bit commitment. Alice has committed herself to a bit, but Bob doesn't know which bit it is. He doesn't know whether she chose heads or chose tails. He just knows that the choice has already been made, and he has the sealed envelope, the encrypted zip file. And then Bob can actually flip the coin, so generate a bit. It doesn't even have to be random, because Alice could make her choice random, so he doesn't need to do it at random if he doesn't want to. But he generates heads or tails, and then Alice will not just announce what was her choice, but she will also announce the password for the zip file, allowing Bob to commit to verify that her choice was actually the correct one. And of course, so this is an example of the same protocol using standard tools on a computer, but when we are doing this in actual applications, we are doing it using different kind of standard tools that are available in standard cryptographic libraries. So what you are doing in actual applications of this is Alice will take any string of random bits she wants to commit herself to, and she will publish, send to Bob, a secure hash function of those bits. So for example, secure hash algorithm 256 will be the thing that she will publish. And then after Bob has made the choices or random choices or shuffling or whatever they wanted to do, then later Alice can announce the original string. Bob can compute the hash and verify that the hash value is okay. And this is one. So for the cryptographic hash functions, one of the standard requirements is that they have to be resistant to collisions. So we don't know any efficient way to produce collisions for the hash function. There is no reasonably efficient way for Alice to create two different strings with the same hash value, and therefore we can trust that the string published in the last step has to be the same string that already existed in the first step. So this is an example of a very trivial cryptographic protocol. Later on in my talk, we will go back to this idea, and we will show how to use it inside as a tool, as a building block inside a more complicated algorithm. Before we do so, I will talk about a few other topics first. Here's one more thing for you to consider. And this is also, in some sense, cryptography, because the need to make sure that something existed at some point in time, before some point in time, after some point in time, and so on, is something that occurs in very many practical applications. And one of the earliest ways of showing that something already existed is the classic TV trope with ransom money, that there are some people, they will, for example, abduct somebody's dog, and then they will send a mail that is cut out from individual letters from a newspaper, and it will say that we have your dog, send us your money, and here's the picture of the dog, and in the picture there is the dog, and there is today's newspaper to show that this is a picture taken 10 months ago. This is a picture that must have been taken only after this particular issue of the newspaper has existed. So in this way, we can very easily show that this particular picture of the dog could not have existed earlier. It must have been taken when the newspaper was published, or maybe later, but it did not have any way to exist earlier. Now, a challenge for you to think about after the talk is, can you do the same thing with physical photography to show the other inequality? So how would you make a picture that could not have existed later? You need to show that this picture was taken at this point in time, or maybe earlier, but definitely not later. What's a good repeatable technique of doing the opposite inequality? And thinking about problems like this one is what eventually led to, for example, a very popular buzzword nowadays is a blockchain, and blockchain is also a tool that is intended to solve this type of problems, making sure that something happened and was recorded at some particular point in time. Okay, and now we are getting to the last big part of my talk, and the last concept I will talk today in this tech talk is the concept of zero-knowledge proofs. So in this particular topic, what's going on is that you have some specific knowledge. For example, you have solved a Where is Waldo puzzle or a Sudoku puzzle, or you know how to solve an NP-hard problem in polynomial time, or maybe something even bigger than that. You have some knowledge, and you want to convince other people that you actually do have this knowledge. But you have to do it in a specific way, because, for example, if you really have a polynomial algorithm for 3 set, then this is a huge thing. And as soon as you reveal how to do it, what's the algorithm, then everybody else will also be able to do it. So maybe you want to try to prove that, yes, I can actually do this, without revealing that you can do it or how your algorithm works, something like this. So how can something like that even be possible, that you can prove beyond any doubt without actually revealing anything? Let's start with some very simple specific cases when something like that can be done. So there is the Where is Waldo, or in English, Where is Wally puzzles, as one of the very nice hardware examples of these problems and solutions. So this is a collection of puzzles that have scenes like this one, and in these scenes the goal is always to find primarily Waldo, who is a character in a red and white striped shirt, but there are also usually others like a dog and so on, and you can spend a lot of time looking for this particular character in many different scenes. And now you have already found him, but you don't want your friends to know where he is in the picture. You just want to brag that, yes, I already know where he is. But if you just show them, then everybody else knows as well, and the fun is over. So what can you do? For this particular problem, we have a hardware solution. The hardware solution is take a large newspaper or any other large piece of paper that is bigger than the puzzle, make a small hole into the paper, cover everything, and just show them the actual character. So if you show the actual character, then now you can say, here he is, I was able to find him, and you haven't shown anything else. So this is the general principle, but this is something that could be only done for this specific puzzle and cannot be generalized. So let's see a different example that can actually be generalized. The different example will be color blindness. So some people have different kinds of color blindness. Usually it's among some specific hues of colors because their eyes are not sensitive enough to be able to tell them apart. The most common type of common blindness is red-green. So suppose you have a friend who is colorblind, you have a red ball, you have a green ball. To you they are different, to them they look the same. And now you want to convince them that you actually are able to tell the balls apart. What can you do? The idea is very simple, and probably most of you, the first thing you would try would be something along these lines. The key idea is a protocol where one person issues challenges and the other makes some responses. So if you are claiming that you can really tell those balls apart, and you know that this one is the red one and the other one is the green one, what you can do is with your friends is they can always take the balls under the table, shuffle them, bring out one of the balls, and you will say this is red or this is green, and they can keep track of the balls also below the table, and they know that you are consistently giving correct responses. And with each correct response, their confidence that you are actually able to tell those balls apart is growing, because if you are just making random guesses, then your probability of making x random guesses in a row is 2 to the minus x. As soon as you get to 50 attempts and all 50 attempts were correctly answered, then the probability of you doing it random is so negligibly small that being killed by lightning is much more likely than you being so lucky. So This is the key idea also in the general implementation of these zero-knowledge proofs, that there will be a protocol with some challenges and some responses, and the person who is giving the challenges will be then convinced more and more that the person who is successful will be able to do those responses is actually in possession of the knowledge. We are still lacking one more aspect of this. So what we have just described is an interactive proof scheme, but we will have also to be able to argue about it being zero knowledge. We will have to show that there is no transfer of information. And in order to do this, I will introduce one more story. And in this story, I will now talk about a story that we probably all know from the Arabian Nights. It's the story of Ali Baba and 40 thieves. So in this story, Ali Baba is a poor woodcutter, and one day he happens to overhear a group of thieves, and he follows them, and he sees that they are able to enter a secret cave by saying the magic words, "Open Sesame," and when they say "Open Sesame," the wall opens, and they can pass through solid rock into the protected cave. And now, what really happened in the story is that Ali Baba wasn't so stupid that we would just steal gold from them or something like that. Ali Baba is smart, and he realizes that stealing gold of the thieves, this is a one-shot thing that doesn't bring any profit in the future, but being able to pass through solid rock by uttering magic words, now this is a skill, and this is a skill that can be monetized. So he now has this new skill. He would like to advertise his new skill, but how to do it? The way the thieves did it is very stupid. If anybody hears the magic words, "Open Sesame," then they will be able just to do the same thing he did, learn the secret, and then they'll be able to pass through walls, and suddenly his new skill will not be valuable if everybody can do it. So Alibaba has to come up with a way of showing off that he has the skill, but without revealing how it is done. And what happened is that Alibaba spent some time searching and managed to locate a cave just like the one that is here on the slide on the right side. And in the cave is almost a circle, but there is a rock wall. It's exactly in the middle of the circle. So anybody who inspects the cave will see a cave that consists of two separate branches, branch A and branch B. And now Alibaba has contacted the DNN Evening News. So this is the Desert News Network. And he told them, "Hey, guys, I can pass through solid rock. Come with me, bring your cameras, and you will be able to show a documentary about it on the evening news. This will be a scoop of the century. Come on, let's go film." So they ventured into this desert. They came into the cave. The crew set themselves up at the mouth of the cave. And now what they did is precisely this type of a challenge response protocol. So Alibaba always goes inside and hides in one of the two branches. The camera crew then enters the cave. They come to the crossroads, and then they will call out the challenge. Either come out from branch A or come out from branch B, from the left, from the right. And Alibaba always successfully leaves from the branch they have chosen. In half of the cases, he can just walk. In half of the cases, he utters the phrase "Open Sesame," passes through solid rock, and then exits from the other side. So just as in the example with the red and green ball, the protocol works in the sense that the DNN Evening News crew was fascinated. So they filmed 30 rounds in a row. Each time they gave the challenge, each time Alibaba exited from the chosen branch of the cave. So yes, it was fantastic. They had a story. They were completely convinced it's true. 30 times cannot be a coincidence. He is actually able to pass through solid rock. We have a story for the evening news. So they drove off and began processing the video footage. So far, what we have is that we are now convinced about having a good proof method. Alibaba actually convinced the camera crew. But what also happened is that there were also two other competing TV stations. There is Foxy News and there is the Baghdad Broadcasting Corporation, and both of them have learned about this scoop and they want to fake their own. So for the evening news, they also want to show off somebody else that, yes, he has the skill of being able to pass through solid rock. So what they did is they used two different methods, but both of them successfully constructed fake news reports. Foxy News, what they did, they just grabbed a random passerby. They recorded 60 rounds. In those 60 rounds, 29 times the passerby was not successful because they were in the other branch of the cave. 31 times they were successful. So what Foxy News did is they cut out the parts where where the passerby failed, and then they only broadcast the other ones. Baghdad Broadcasting Corporation also saved some more material, because what they did is they had a paid actor. They told them in advance what the sequence will be, and then of course they were able to film 30 successful attempts. So what happened that evening is that each of the three TVs had their own segment about a different person, saying that, hey, look at this footage, this person is able to come through walls. And after seeing all of those footage, everybody else just shrugged and said, okay, they're all faking it. And this is the big picture idea of how we can prove about some kind of a protocol that the protocol is zero knowledge. Exactly using this technique, if you are able to successfully fake footage that is indistinguishable from the actual one. So if you are just after the entire fact examining protocols, then you cannot tell apart a protocol that comes from the original proof and the protocol that comes from something that was generated in using probably one of these techniques. And if you are unable to tell those apart, then it means that for a third party, for somebody who's just watching it on the news, the footage doesn't actually contain any information about how to pass through solid rock or whatever it is we are trying to prove without revealing. So it's kind of a two-way street. On one side, you are able to convince, beyond any level of doubt, the person who is actually giving you the challenges. So the person who is giving the challenges will actually be convinced at the end that you do have the knowledge you claim to have. But anyone else who is not involved actively in the protocol, who is just observing it from afar, then they will learn exactly nothing about how are you doing what you're doing. So here it is once again on the slide. Alibaba was successfully able to convince the camera crew because they were the ones who were choosing the challenges, but the recording doesn't reveal this secret because others who don't have the knowledge can produce such recordings. And again, this was a story, but this is something that has actual practical applications, including some modern forms of cryptocurrency and the related stuff, and even more notably authentication, because in some sense authentication is the place where you want to do things like this. You know a secret, something along the lines of your password. You want to convince the other side that it's you, that you know the secret, but you want to do it without revealing anything. For standard password authentications, usually we use different protocols that kind of use other techniques to establish a secure communication channel, and then you can actually reveal the password. But in some other applications, this is exactly the way it's done. So we choose a problem that is kind of difficult to solve, and then you use a zero knowledge proof to show that you are the one in possession of this particular solution. So as one of the very last things in today's tech talk, here's one practical example of a zero knowledge proof. So suppose you know how to find a Hamiltonian cycle in one particular very large graph. Maybe you have a general algorithm, maybe you just know it because you generated the graph or for some other reason. And now you want to prove that you know the actual where the cycle is, but you want to do it without revealing anything about the location of the cycle. So what can you do? Let's first imagine it with pen and paper. What you do is you choose permutation of the vertices of the graph. So you assign new numbers from 0 to n-1 to the vertices of the graph. And then you take a bunch of pieces of paper, and onto each of the pieces of paper, you will write one edge of your new graph. So you will look at all of the edges of the original graph. For each of those edges, you will have one piece of paper, and on each of those pieces of paper, there will be, for example, 7, 43. So these are the two vertices connected by an edge in your new numbering. And now the person whom you are trying to convince, the challenger, can choose one of two possibilities. One possibility is that the challenge is, I want to see that you actually did what you are claiming to do, that you actually just relabeled the vertices of the graph. So if they issue this challenge, you will just reveal the permutation of vertices. So you will say vertex A is 17, vertex B is 34, and so on. And they can examine all of your papers, and they can verify that together they are just exactly the set of edges of the graph. The other challenge can be that they want to see the cycle. And if they want to see the cycle, then you will reveal exactly n of your papers, and these will be the papers that contain the edges that form the cycle. As you know the cycle in the original graph, you know it on those papers, and then you can reveal exactly those. And what the challenger sees is they can verify that this is really a cycle that visits each of the n vertices once, and that's it. As the numbers are random, then they have no information about the position of the cycle in the original graph. And that's the protocol. So to conclude my talk, here are two more challenges for you to think about after the talk is over. So question number one is that suppose that your local news have just hired you to fake the recording for these Hamiltonian problems. So you should do the same thing as the other news networks did for Alibaba. Pretend that you know how to solve the problem and generate a faithfully looking recording of the challenge and response protocol to show that this is actually a zero-knowledge protocol and that nobody else learned anything about the position of the cycle in the graph. So this is more like a challenge to make sure that you understood what I was talking about, and this shouldn't be hard. Something a bit more challenging, where you will need to spend a little bit of time thinking about how to modify what you have already heard about and seen during the talk, is suppose you have just solved a really difficult classic Sudoku. So again, a shout out to a good YouTube channel, Cracking the Cryptic. And so you have taken a Sudoku puzzle, you have solved it, so you now have the grid of 9 by 9 numbers, and you want to show off that, yes, I have solved this very difficult Sudoku, I can do a swordfish technique and whatever. And you want now to convince your friend that you have the solution, but again, in a zero-knowledge way, without revealing anything about the solution, just being able to convince them beyond any shadow of doubt that you can actually do this. So how do you do it? So try coming up with a pen and paper protocol where the friend is issuing challenges, you are doing responses, and together you will be able to convince the friend that, yes, you actually do know a solution to this Sudoku without actually revealing that this is what's going on. Okay. So that's it. I hope you enjoyed my slightly incoherent ramblings on different topics I find interesting in the area of cryptography. And if you have any questions, then now is a good time to type them into the YouTube chat, and I will try my best to answer them and talk about whatever interests you a little bit more. If we don't have any questions, it's also all right. I hope we'll enjoy the rest of the NWERC. Yeah, good luck to you in the competition. Many good ideas, with very few bugs, useful debugging. I will share one of our dirty secrets. When we are competing in the ICPC back in the day, one of the very closely guarded secrets was the technique when you are helping somebody else debug their code, think that they are idiots. So what this does is it's when you're competing in ICPC, the other people on your team are smart. You are smart as well. Everybody in the competition is smart, and it's very easy to slip into just nodding your head and agreeing with everything the other person says. And if you start the entire session by saying to yourself, "Hey, my friend, he's dumb. I don't trust a word he says," then you are switching yourself into a mindset where you are actually actively trying to find the mistake that they made. And this was helping us in the ICPC contest. And it's also more fun because when you can find your friend's bug, then you can make fun of them also after the contest. So I'm glad at least the people who commented in chat enjoyed the talk. And yeah, thank you for your attention once again. That's it from me.
There are parts of our world where light can't reach. Divides that are too wide for rivers to flow. But technology has the power to help. In remote areas of Nigeria, connectivity brings new life to local communities, opening doors to trade, banking, better education, and healthcare. In Bangladesh, digital training has given more than 240,000 women new opportunities in life. With AI, deaf children everywhere can translate written words into sign language. So no child misses out on the joy of storytelling. In Central America, upcycled smartphones help rangers detect poachers and loggers, keeping rainforests safe for everyone. Our planet may not be perfect, but digital technology can help make it better. In the next 5 years, we want to work together with our partners to help 500 million more people directly benefit from digital technology. Focusing on healthcare, education, environmental protection, and economic equality. Tech for all. Pass it on.
Thank you again, Ms. Ok, for a great talk. I at least enjoyed it a lot, and I think the contestants did as well. Next up, we're gonna have solution slides for the practice session from the jury. So I'd like to welcome the jury on stage. Take it away.
Hello. So the first problem was Aurora Borealis, and there you are given n pairs of time and location, and you have to find the minimal length of cloud that can move at most at speed 1 meter per second, and you need to cover every pair of time and location with this cloud. And yeah, first step is to just sort the input by the times. And then the idea is that for a given length of the cloud, you can easily check if you can cover all those pairs. This can be done by keeping track an interval of all possible left ends of the cloud. And that you can do for each time. And each second, this interval will increase by 1 unit to the left and to the right. And if there is such an input pair of time and location for the current time, you need to adjust the input, the interval of starting points, depending on that position x you're given. And in the end, you just need to check if there is a valid point in this interval after each update you do to it. And if that's true, the length of the cloud is valid. And since this is monotone, you can binary search the length of the cloud, which results in a time complexity of n log n. There's a challenge. You can also solve this without a binary search. Have fun with that.
Okay. Right. Next up is problem B, basalt breakdown. So in this problem, you were given the area of some regular hexagon, and you needed to calculate its perimeter. And to do that, first, if A is the side length of the hexagon, then there's simple formulas for both the perimeter, which is 6 times the side length, and the area, which can be computed by noticing that a hexagon consists of 6 equilateral triangles. And then you take these two equations, put them together, solve for the perimeter, and then you get a formula that you can just use to get the solution. And then, right, this was solved by 100 teams before the freeze. And then in this specific instance, there was also an alternative solution because NWERC was an online contest this time. So next slide, please. And you could just plug in the problem statement into Google, and it turns out that Google actually does give you a solution for the problem in shape formula, and also a nice handy tool that you can use to get the answer for any parameter. So that's nice. Right, next up, problem C.
Right, problem C was our interactive problem, and here you got n coins, most of which had the same weight, but there was one which had a different weight, which could either be lighter or heavier. And you were supposed to figure out which one it was by weighing one coin against another, and doing this at most n over 2, well, the ceiling of n over 2 times. And I guess the first step that you would do is just try some random coins, weighing them together. Trying the first and the second, trying the third and the fourth, etc., until you find a pair which does not have equal weight. And if you do this, this might take up to about n over 2 queries, but in fact it only takes a floor of n minus 1 over 2, because if you try all the pairs except the last one, and all of the weights are equal, then you know that the last pair will have unequal weight. And then finally, you need to figure out which one of the 2 coins in the pair is actually the odd one out. And you can do this by comparing it to another coin of which you know that it has the correct weight. If that last coin that you checked has the same weight as the other one, then you know that the last coin in the pair is actually the odd one out. 81 accepted. Lots of submissions, so I think people have used the testing tool hopefully as well. I think that's it for this part.
All right, so then we go to the clarifications on language statistics. As you can see, most people use C++, then followed by Python, a little bit of Java, and even less Kotlin. Let's do the clarifications. So you should always ask your question in English, and we will answer in English. You will get penalty time for submissions that fill in the sample. So if you want to avoid this, test this locally. You will not get penalty time for compiler errors. If you want to know the exact compile flags we're using, go to the website nwerc.eu/system. If your submission uses too much memory, we do not have a memory limit exceeded. You will just get a runtime error. In general, you will get a runtime error whenever your code exits with non-zero, when your submission exits with non-zero code. For interactive problems, this is a bit more tricky. So we guarantee that if you get the wrong answer, you printed at least something wrong. If you get time limit, your solution was hanging. This can be for a couple of reasons. Maybe you didn't flush. Maybe you said you were going to print, for example, 10 integers. You printed only 9, and then we're waiting for the 10th. This can also be a reason for time limit exceeded. And runtime error is whenever you exit with non-zero code. And then for Kotlin, you need a main function. So you do fun main. Oh, it says KS there. This should be KT. Sorry. So use the .kt extension, and if you have a file.kt, use file.kt as the main class. Then some more small FYIs. We do not provide PDFs for the problem statements. We do not provide a single zip for everything. You can use the CADDIS online interface for this. You will not see the number of test cases you passed. This was possible today. We will fix this for tomorrow. You will not see the CPU time you used. And you cannot hide the IDE widget, but I saw in the Discord there's a workaround, but use at your own risk. I think we're also going to do live questions now. If you have questions, ask them on the YouTube stream.
Yeah. Sounds good. So,
And you're checking this.
I'm checking this, so if you have any questions, you now have a couple of minutes for any final clarification requests that you did not think were not answered right now.
I hope you enjoyed the test session, and hope you asked or tested all your things, and otherwise good luck for tomorrow already.
Yeah. I'm not seeing any questions. So, which C++ version is the system using? So this is answered on the NWERC.eu page. If you go to the official website of the contest and go into, there's a link at the top called System, and there you can see the versions of all of the compilers that we use, as well as the flags that we pass to the compilers. I think for C++, I don't remember the compiler version,
20.
but it's, yeah, STP,
I don't know.
STP ++ 20, I think.
Check the website.
Yeah. In the jury presentation of problem C, it said n-1 coins, but shouldn't that be n coins?
N of the same weight and 1 of the other weight.
So n of the same weight,
N minus 1 of the same weight.
n-1 of the same weight, and 1 of the other weight. Yeah, Kniffen posted the command for that the compiler use, or that we use for compiling C++ code, and we're using std equals GNU ++20. Okay, any final question? Another question, why does Python submissions have a main class field? I thought that was only for Java. So in the interface, if you edit, or if you're going to submit some code, you can select the programming language, and you'll get an editor, and at the bottom there's an input field which says main class. So for Java and Kotlin, this makes sense. This is the class that will be run for this code. For Python, this is almost the same, but if you submit multiple Python files, this is basically the name of the file that you want to be run. So in the editor, you can create new files, or even submit multiple files at the same time. this is the name of the file that you want to be run if you have multiple files. I think we're going to rename this to something else like entry point for Python because that makes more sense than main class. I hope that answers your question. But in most cases, if you're submitting a single Python file, it's just the name of the Python file. So main.py would just be main.py as the main class. How long can we still use the judging system today? To set up the submit client, I think we're going to start preparing for tomorrow's contest pretty soon. So you may have half an hour, but I think we'll be taking it down probably relatively soon. Yeah. So I think that's it for the questions. In about 48 minutes, we have a sponsored talk from Huawei, I believe. Yeah, so we'll be back at 1 p.m. Icelandic time or 2 p.m. GMT +1. So we'll see you then. Ciao.
ICPC gold medalist and in this short video I will be using Kotlin to solve a sample algorithmic problem that appears sometimes on coding interviews. This problem will concern finding dictionary words inside the rectangle filled with letters. Let's go to an IntelliJ IDEA window to discuss the problem and solve it in Kotlin. First of all, I'd like to thank Solontus_ and Lalit Kundu for bringing up this problem on different websites. So the problem is we have a rectangle filled with English letters and a set of words that we will call dictionary. And the question is, which of these words can be read in this rectangle if we are allowed to read horizontally or vertically and turn 90 degrees as many times as we want. For example, in this rectangle, we can read the word Kotlin or fun or file according to these rules. Let's hard code the rectangle with letters into our program. So this will be a row string with all these tabs and line feeds that we will deal with later. And the dictionary will be also stored as a row string that needs some processing as well. The rectangle row string has all these tabs and line feeds, so let's first remove the tabs by trimming all the indentation of the string. And now we have a single string with letters and line feeds, so let's split the string with a line feed character to receive not a single string, but a list of strings that are horizontal lines of the original rectangle. We can print the resulting variable to make sure we got our trimming right. And now for the dictionary line, let's make sure it's uppercase, just as all the letters in the original rectangle. And now with this uppercase single string, we can split it by a comma and a space to receive the list of single words of the dictionary. Actually, knowing that I want a lookup operation in this data structure to be quick, I can make this a set. Now let's actually code the method that is going to do the main work. I propose a recursive implementation over here, so let's discuss the signature of our method. For now, let it receive the coordinates of the cell that it is currently processing, but we will update the signature with some more arguments later. When we enter an instance of this recursive method, we are standing in the cell with coordinates x and y, and in general case, we want to make a recursive call into each of the 4 neighbors of this cell. How do we organize the iteration over all 4 neighbors of this cell? Well, I propose a list of vectors that show the directions towards all the 4 possible neighbors. In this list, I will be using Kotlin pairs to store the direction vectors. Now, in the recursive call, I can iterate over all the possible shift vectors, and in this for loop, I will be using multiple variable assignment to introduce 2 variables, the x shift towards the new neighbor and the y shift. With these 2 variables, I can calculate the coordinates of the next cell that I will visit in the upcoming recursive call. We have the new x coordinate and the new y coordinate, but these 2 coordinates can show outside the rectangle, in which case I want to ignore this iteration of the for loop, as this shift vector is useless. Also, I definitely want to know the letter that is located in these new coordinates if they indeed show inside the rectangle. So let me write the code that does these 2 things simultaneously. I could have written a simple code that makes a direct access to the 2-dimensional array by the y coordinate and then by the x coordinate. But this code raises an exception in case a y coordinate or an x coordinate goes outside the rectangle. So let me rather use nullable objects here that Kotlin handles so nicely. And instead of taking the horizontal line with such index, I will rather use the getAllNull method that will give me the horizontal line with such index or null in case this index is invalid. For this object, I want to do something only if this object is not null. So I put a question mark here, and then I apply the same method to receive the value in the certain index or null if this index is invalid. This object is the letter located in the desired coordinates or null if at any point the y coordinate or the x coordinate was pointing outside the rectangle, in which case I want to disregard the entire iteration of the for loop, which is exactly what a continue operator does. So if I have reached this point of code, then I didn't run the continue operator, and therefore my coordinates are showing to the actual cell and not outside the rectangle. So I can make a recursive call to these new coordinates. So over here I make a recursive call to the new cell that I'm sure is not a place outside the rectangle. However, this resulting code is an awful example of the infinite recursion, because each instance of my method always runs several other instances of the same method for the neighboring cells and they do the same recursively, and so on and so on and so on. So we need to stop our recursion at some condition. In order to do this, let's change the signature of our method so that it receives the word that has been already read during the previous recursive calls. With this word, we can stop the recursion if this word is not a prefix of any word in the dictionary. We need to pre-calculate before the recursion the set of all the prefixes of all the words in the dictionary. Let's take our dictionary, and I could have used the map method to receive the list of lists of all the prefixes of the words in the dictionary. But what I actually need is the concatenation of such lists. So instead of the map method, I will use the flat map method that will do exactly the thing. Inside this flat map method, I want to receive the collection of all the prefixes of the given word. So let me introduce the word variable that I will be working with. And here I need to construct a collection with its prefixes. It will be a list, and the length of this list will be the length of my word plus 1. And for each index, I want to generate the prefix of my word with the corresponding length. So from my word, I take the corresponding number of letters. And once again, since I want the lookup operation to work quickly, this overall collection should be rather taken as a set, not a list. Now let's get back to the recursive method. In case the already read word is not a prefix of any valid word in the dictionary, just disregard the entire recursive call. And if the current read word is exactly a word from the dictionary, let's print it to the answer. And the recursive call to the neighboring cell should also pass the correct argument to the method. So it will be the already read word plus the letter that we have seen in the new cell. Now we are ready to make a call of the recursive method for each cell of the rectangle. In order to do this, we iterate over all the possible values of y coordinate, and instead of writing the specific lower and upper bounds, I'd rather write the indices of the rectangle, because this is exactly the values for y that I want to iterate over, and I will not make a mistake by +1 or -1 in such code. Now, for the x-coordinate, let me also write some code that will be safe from +1 or -1 mistakes. So these are the indices of the horizontal line, for example, number 0. And for each y and for each x, I make a call to the method search with these two coordinates, and the word that I start with is the word consisting of a single letter in these coordinates, passed as a string. These for loops will run the recursive search from each starting point, and these recursive searches will print all the found words to the output. So let's run this code to find all the words in our rectangle, and we see that our rectangle contains all the words from the dictionary except for the word null. The basic problem is solved, but the important exercise yet to be done is to forbid ourselves from coming to the same cell several times, because it's a very natural thing to disallow, and our code still allows such behavior. So I'll leave it as an exercise for you, or probably we will do this in some other later video. Thank you for watching this video. Have fun using Kotlin and other programming languages, and good luck in your careers. Bye.
Of the PTs as part of the Huawei Technology Center, OSTC. So who are we? What do we do? Why do we do it? Oh, and how do I poke an email to you? Here you go. We are a team focusing on open source projects, in particular Open Harmony OS. We all come from various areas of expertise, from firmware, kernel, all the way up to the rainy clouds. But we are all connected by an open source culture with experience in well-established open source projects like Linux, Zephyr, Yocto, to name a few. So we came together and started to build Open Harmony, an open source project which targets a all-scenario intelligent ecosystem. Say what? Basically, we work on a product baseline that is vendor lock-in free. No matter the device, you can adopt the project using the same unified user experience, and is completely done openly and transparently. That probably sounded a bit soft, and I know you are the kind of people who like to tinker with things. So, digging a bit deeper into the architecture, I would say that it allows you to plug in different kernels, Linux, Zephyr, etc. On top of which, we use a common user space base system. That, along with using Yocto as build system, would probably resonate with your experience and general open source exposure. What we do is bring that into an ecosystem that works in a unified manner. And not only that, on top of those layers, we have what we call a distributed virtual framework. Just imagine that you wouldn't be limited by the resources on your device. You would be able to use a pool of resources that you have in your house and use those resources by the application in a transparent way. In other words, various devices can form a resource pool and expose an API that applications can use. If that caught your attention, you will be interested in checking things out, get involved, or contact. As I already said, everything is public. So you already have access to code repositories, developer guides, and even have a platform to chat with us. But let me show you. Our home is a GitLab instance. You will find in the wiki a 4-step guide on how to use things around. You can download the software, you can use it, and you can hook your own components, your own software stacks to it. You can get information about the supported boards and how to build for those boards. You can find information about the documentation. You can find information about how to contribute to our code and our documentation. This is our project wiki. You also have a sub-project that is Open Harmony OS specific and will provide you with all the internals of the platform, the components, the build system layers, and so on and so forth. So, why would I get involved? 5 points. Code is open source, inspectable, and peer-reviewed. Multiple eyes guide the quality of the code. We provide governance that is transparent and includes multiple parties. Flexibility in features, suppliers, and roadmap choices. In other words, technology freedom. It's economic, as it combines efforts and investments in between multiple parties. And least but not last, it recognizes you, the individual developer, access to a shared learning stage, and become an opportunities hub. There you have it. For those of you not bored with my technical bits, you will find Hibo interesting. Without further ado, I'll pass it to Alexander.
Hello, I'm Alexander, and today I'll present Hibo, a submission that won the NWERC's 2020 Black Box Optimization Challenge. To set the scene, our goal is to maximize a black box function by finding a probably mixed variable x. Such a setting is widespread, with ubiquitous applications ranging from molecular design to neural search and AutoML. One way in solving this problem is to follow a Bayesian optimization scheme that executes the following 3 steps. In the first step, a surrogate model, usually a Gaussian process, is fit. With that acquired, the second maximizes an acquisition to determine new search points. The third then evaluates new inputs by querying the black box, and the above process repeats. During the surrogate fitting, one typically assumes a Gaussian likelihood in the GP model. Unfortunately, across the competition data, noises can be highly complex, leading us to realize the first problem of non-Gaussian likelihoods. Apart from the likelihood assumption, we realize a second problem, choice of acquisition functions. We know there are different types of acquisition functions, EI, PI, and LCB. They all have a shared goal to help determine which points to next evaluate in the black box function, differing in how they trade off maximizing expected return with uncertainty-driven exploration. However, it is not clear which one works best in general, an important problem when applying BO to a wide variety of tasks, such as in this competition. Now, let us understand how we dealt with non-Gaussian likelihoods in Bayesian optimization. We use a learned nonlinear transformation on the input and a fixed nonlinear transformation on the output to better deal with non-Gaussian likelihoods. We use a warped Gaussian process on the input. Specifically, we use the CDF of the Kumar-Aswamy distribution, a bijective transformation that remains between 0 and 1, and importantly, only introduces 2 additional parameters, A and B, per input variable, as shown in the equation in the top left. Additionally, we apply a power law transformation on the output variables, as shown in the equation at the bottom left. This transformation reshapes the target data to better resemble a Gaussian distribution, as shown in the plots in the bottom right. Having dealt with problem 1, we can now detail how we tackled the second. What acquisition function do we use and how do we optimize it? Why pick one acquisition when you can hedge your bets and pick multiple? We use a multi-objective acquisition function instead. As shown in the plots at the top right, each individual acquisition has a differing maxima point. By finding a Pareto set between these acquisitions, produce a diverse and informative set of points to be evaluated next in our black box function. But how do we find this Pareto set? We use a multi-objective evolutionary method, NSGA2, to find a Pareto set. Importantly, this method supports mixed variable mutations and crossovers, further customizing HEBO to the competition data. Apart from the above, we also realized very interesting properties in the data. Please focus on the left plot. When conducting offline dataset analysis, we observed correlation between a regularization parameter C and model accuracy up to a certain region. Zooming into this region, on the right-hand plot, we see no clear correlation. We conclude that the best method to search would appear to be random. Thus, we wanted to design a method which was able to perform coarse search up to a promising region and then fine-grained random search within this region. This led us to creating a novel robustness technique, which allows our Bayesian optimization algorithm to resort to random search when the learned likelihood noise is high. This is achieved through adding on a noise dependent on the likelihood variance onto the posterior mean of the Gaussian process. As you can see in the plots, as likelihood noise level increases, we similarly get increasingly random search around the desired region. All additional components are shown with their corresponding rating as to how effective this improvement was. Overall, These components constitute HEBO, our submission that won this NWERC competition. Thank you very much for listening, and good luck with the competition.
All right. So for those of you that are still with us, we're gonna do a quick test run of the resolver. So the resolver is so you've been competing in this practice session. You may have noticed that during the last half an hour of the session, all of the submissions on the scoreboard were marked as, I think, gray. And what that means is that we haven't displayed the final verdict for those submissions, for the submissions in the last half an hour. Tomorrow in the main contest, these will be all the submissions made in the last hour of the contest. So you won't know what the final scoreboard looks like until we run the resolver. So we're gonna head into the resolver now for the practice session. So this is what the scoreboard looked like at the end of the contest, while we still had frozen submissions. You can see them there as yellow. Cells that are green are accepted submissions, and red are rejected submissions. So we're gonna go to the bottom, and we're slowly gonna make our way towards the top and resolve the submissions that are still frozen. So starting at the very bottom, going a little bit fast, but here we can see that more Ballonetics solve B, KTU3, okay, J++, it's not a bug. Holland King make an attempt on B and they get it. Dream Team, the Dead Coders Society, going a little fast. Focus out, almost retired. To B or not to B, have 3 submissions. I didn't solve A, and they solved C. Congratulations. Programming Team, KTU3, all solved. No submissions left. Holland King, fail on C. Fuzzy Spoon, gets C. Sydney's Cat 3, Star Platinum, Hasso on Rails, gets A and moves up. Control Alt Delete moves up. Trainwrecks Plus gets accepted on C and moves up. Vilnius Tech 3 has no more submissions. Cauliflower, Monkey Move, Funky Monkeys. NWERC 1 Framework makes a submission but fails. Fork Bombers try C but fails. However, we stop here because Fork Bombers are the Luxembourg champions. Congratulations. Okay, let's continue. Bubblegum Bitset has nothing left. Webbase moves up by solving C. Fuzzy Spoon has nothing left. Suits attempts A but fails. Pip install Java has nothing left. Am I ready for Fang now? 1-1 Pulse gets A accepted. Hosse and Rails get C accepted and moves up. Wonder of You. Oh, they get A. Woohoo! Webbase has nothing left. We're terrible with names. There's nothing left. Vilnius Tech has nothing left. Coder has nothing left. Hold of Stat tries A but fails. NWERC 2 gets accepted and moves up. Polar's Bros. Oh, they get accepted and move up. Woohoo! Congratulations. Pionar fails. DM Gang has nothing left. Mangolasi Fan Club. Oh, they solved A. Congratulations. Epsilon Streak. Yes, that's another solve for them and they move up. Seppi Ask solves A and moves up. Invenium Lam solves A and moves up. Crystal Math 2 solves A and moves up. Roboman has nothing left. Famous Unicorns fail on A. Revealute get A. 3 Pete Zoners, Pest Owners move up. Risk It tries A but fails. Placeholder 1-1 Pulse with no more submissions. And that's pretty much it. So above, all of the teams have solved all 3 problems. So now we can just enjoy as we move up the scoreboard. R/WTH, Fabulous Unicorn with all accepted. Mangolasi Fan Club, Frederick's Minions, woohoo! Strustrup Smukkehar, Proger Skriben, Seppi Ask, Bartumus Krats Jr., Ballandirner, No Latte, F-Slangastrik. And we stop here because F-Slangastrik are the Icelandic champions. Congratulations. Next up is Dynamic Programmers. All done. SOP, all done. 5 engineers. OWL, First Class Confusion. We stop here because First Class Confusion is the Norwegian champions. Congratulations. Hope it passes are all done. Hip Hip Hora are all done. And we stop here because they are the Belgian champions. Congratulations. Well done. Next up is Night Raccoons, all done. Tarzan, all done. Unicode Garbage with all accepted. The Turbofish with all accepted. I don't know what that Unicode letter is. Let's go. And SP3D version 1.2, we stop here because they are the Estonian champions. Congratulations. 1.2, Spreaders. Bulbasaur, accepted. Cyan Forces. Oh, and we stopped there because they got the first solve on C. Well done. Tumbledore. We stopped there. They are our first bronze medalist. Tumbledore with 3 problems solved. Congratulations. Next up is Coolness Overflow. 3 problems solved. Stop here because they are our next bronze medalist with 3 problems solved. Congratulations. Binari Pulut. They are our 3rd bronze medalists with 3 problems solved. Congratulations. Temporary. No more submissions. Bronze medalist, the Finnish champions with 3 problems solved. Congratulations. Zoomers with 3 problems solved are our first silver medalists. Next up is Scream and Shout, or Shout. Our second silver medalist from with 3 problems solved, and are also our Danish champions. Congratulations. Imposters are our next silver medalists with 3 problems solved, and the UK champions. Congratulations. Hexaflexicons, first to solve problem B, also silver medalists with 3 problems solved. Congratulations. Order of square root of -1, 3 problems solved. Our gold medalists, our first gold medalists, and the Lithuanian champions. Congratulations. Then we have easy peasy. The Swedish champions, gold medalists with 3 problems solved. Congratulations. Sackfold Go Burr, the first to solve problem A, are our next gold medalists, the Dutch champions with 3 problems solved. Congratulations. And finally, Chatsiki Tartare. 3 problems solved are the German champions, as well as our absolute first place gold medalist. Congratulations. All right. That's it for the resolver. I hope you enjoyed that. This was good practice for tomorrow. I hope all of you, the few of you that are still watching, tomorrow that you're gonna spam in the chat when we resolve this. Every time someone solves something, you do ah, and every time someone gets rejected, no, that was incorrect. well, okay. When someone gets rejected, you do ah, and when someone solves the problem, you do woo. Spam that in the chat. Okay, so in a few minutes we'll have a sponsored segment from Huawei. I hope you join us for that. See you in a couple of minutes.